Hello friends, in the last video we have seen the exercise 1.3. In that exercise we find out the amplitude and the argument of a complex number and basic algebra of a complex number. Now in this video we will see the de Moivre's theorem and the complex cube root of unity. I am explaining the first of all de Moivre's theorem and the complex cube root of unity, and then exercise 1.4. In this exercise I had selected the question first of all 1 to 5 and the 7, and the remaining questions will be in the next video. Now let us start de Moivre's theorem and the complex cube root of unity and the examples depending on these two topics. Exercise 1.4. Let us start now. Now let us start de Moivre's theorem. If the Z1 is equals to R1 e raised to I theta 1 and Z2 is equals to R2 e raised to I theta 2, then Z1 into Z2, that is a product of these two numbers, is equals to R1 e raised to I theta 1 into R2 e raised to I theta 2, that is the product of their magnitude, means R1 into R2, and the sum of their amplitudes, that is the e raised to theta 1 plus theta 2 bracket complete into R. That is, if two complex numbers are multiplied, then their moduli get multiplied, that is R1 into R2. This is the modulus. That is the modulus of the complex number, and the arguments are added, that is the theta 1 plus theta 2. This is for the division, multiplication. Now we will see the division, that is the Z1 upon Z2 is equals to R1 e raised to I theta 1 upon R2 e raised to I theta 2, that is equals to R1 upon R2 e raised to theta 1 I in bracket theta 1 minus theta 2. This is very simple law of the indices apply here, that is a raised to m upon a raised to n is equals to a raised to m minus n. In the same way, that is if one complex number is divided by the other, then their moduli are get divided, means what, R1 upon R2, and arguments are subtracted, get subtracted, means we have seen that theta 1 minus theta 2, that is theta 1 minus gets argument get subtracted. Now the de Moivre's theorem. It's very nice and interesting. This theorem is proved by the method of induction in the next chapter. Here we'll see only the statements of this theorem, and it's very simple and easy. De Moivre's proposed the following theorem for finding the power of a complex number, that is z is equals to r in bracket cos of theta plus I times sin theta. Then if z raised to n is equals to r in bracket cos of theta plus I times sin theta bracket raised to n, that is equals to r raised to n in bracket cos of theta plus I times sin theta bracket raised to n. And now this is very important. r raised to n is equal into cos of n theta plus I times sin of n theta. For example, that is a cos of theta plus I times sin theta bracket raised to n is equals to cos of n theta plus I times sin of n theta. Means what? Whatever the power, it is multiplied with the at angles, with that angles. That is a cos of theta plus I times sin theta bracket raised to n. Then it is written in this manner. That is a cos of minus n theta plus sin of in bracket minus n theta. Cos absorb the negative sign and sin reflect the negative sign, that is the minus I times sin of n theta. Cube root of unity. Now also this is very important, and the examples in matrix also ask on the cube root of unity. Now see this. That is number 1 is called unity. Number 1 is called unity. Let x be cube root of unity. Therefore x is equals to cube root of 1, that is, take cube on both sides, then you will get x cube is equals to 1. Apply the formula x cube minus 1, that is equals to 0. A cube minus b cube in first bracket, a minus b in second bracket, a square plus ab plus b in this manner. X minus 1 into x square plus x plus 1 is equals to 0, and that's why you are getting x minus 1 is equals to 0, or x square plus x plus 1 is equals to 0. Now we cannot factorize this. Therefore, we will apply formula method. X is equals to ax square plus bx plus c is equals to 0. Then the formula is x is equals to minus b plus or minus in root of b square minus 4ac upon 2a. And by using this, you are getting x is equals to 1 or x is equals to minus 1 in root of plus or minus 1 minus 4 upon 2. That is a minus 1 plus or minus in root of minus 3. Again, minus 3 can be written as 3 into 1 and minus 1, that is a minus 1 means I square, and in this manner you are getting the roots x is equals to 1 or x is equals to minus 1 plus or minus in root of 3 into I upon 2. The cube root of unity are 1 and minus 1 plus root 3i upon 2 and minus 1 minus root 3i upon 2. Now here one root is real and other two roots are complex because they are multiplied with imaginary number r. Now here one root is real and the other. These two are again the complex conjugate of each other. That is, one is a minus 1 plus I root 3 upon 2 and another is a minus 1 minus root 3i upon 2. Now here consider that is a minus 1 plus I root 3 upon 2, and if we square it's a first root. Now see this, the very interesting it is, if we square the minus 1 plus I root 3 upon 2, then what you are getting, that is the minus 1 plus I root 3 bracket square upon 4, 2 square. Now expand this by using the formula a plus b bracket square, that first term square minus 2 into first term into second term plus second term square, that is you are getting 1 minus I root 3 minus 3 upon 4. That is 1 minus 3 means what? It is a minus 2. That is 1 minus 3 minus 2 I root 3 upon 4. That is a minus 2 I root 3 upon 2. Take 2 as common. Then you are getting the minus 1 minus I root 3 upon 2, and this is nothing but third root, which is the last root. That is the square of the first root, second root, get the last root. Now if omega is equals to minus 1 plus I root 3 upon 2, then omega square is equals to minus 1 minus I root 3 upon 2. That the roots are 1, omega and the omega square. Now see this exercise 1.4. Find the value of omega raised to 18, and therefore omega raised to 18 can be written as omega raised to 3 bracket raised to 6. But what is the value of omega raised to 6? And that is equals to 1. Therefore omega raised to 18 is equals to 1. That is omega raised to 21 can be written as omega cube and bracket raised to 7. Omega raised to 3, the value of omega raised to 3 is 1. 1 raised to 7, that is equals to again 1. Omega raised to minus 30 can be written as 1 upon omega raised to 30, that is equals to 1 upon omega cube and whole bracket raised to 10. Again the omega raised to 3 is 1. 1 raised to 10, that is equals to 1. Omega raised to minus 105, that is 1 upon 105, that is equals to 1 upon omega cube and bracket raised to 35. Again its value is 1 over. If the omega is a complex cube root of unity, then show that the value is 7. Remember, the result omega cube is equals to 1. 1 plus omega square is equals to 0. I am mentioning here these two formulas indirectly. That is omega cube is equals to 1. 1 plus omega square is equals to 0. Now see this LHS, that is the 2 minus omega in the first bracket and 2 minus omega square in the second bracket. Normal multiplication is there, that is the 2 in bracket 2 minus omega square minus omega in bracket 2 minus omega square. If you multiply it, then you are getting the 4 minus 2 omega square minus 2 omega plus omega cube. That is the 4 minus 2 in bracket omega plus omega square plus omega cube, and that is 4 minus 2 into minus 1 plus omega. Value of the omega is 1 there. Therefore 4 plus 2 plus 1, and that is equals to 7, and this is the RHS. Therefore LHS is equals to the RHS, and hence it is approved. In the next example, 1 plus omega minus omega square is equals to 64, and therefore now consider again LHS. 1 plus omega minus omega square. Now it is written, there is written that 1 plus omega means what? Minus omega square. Now see this, 1 plus omega square is equals to 0. Now he is substituting the value of 1 plus omega, that is a minus omega square. And minus omega square and minus omega square, that become minus 2 omega square bracket raised to 6. That is minus 2 raised to 6 and omega square bracket raised to 6. Minus 2 raised to 6 means 64, and omega square can be written as omega cube and bracket raised to 12. That is omega cube raised to 4. That is omega raised to 12 can be written as omega cube and bracket raised to 4. But what is the value of omega cube? Is 1. 1 raised to 4 is again 1, and the answer is 64, and it is RHS. In the next, that is in bracket 1 plus omega bracket cube minus 1 plus omega square bracket raised to 3, that is equals to 0. Therefore in the LHS, that is 1 plus omega minus in bracket 1 plus omega square bracket cube. Now again see this, 1 plus omega square is equals to 0. Now what is the 1 plus omega? The value of 1 plus omega is minus omega square, because 1 plus omega and the omega square to the right hand side, it becomes minus. And what is the value of the 1 plus omega square? It becomes minus omega. If you substitute, that is a minus omega square bracket raised to 3, it is a minus omega raised to 6. And minus omega bracket cube is minus omega cube, and minus minus become plus, and that's why you are getting the value, that is minus 1 plus 1, that is equals to 0, which is the RHS. Therefore LHS is equals to the RHS. Now for the example, 2 plus omega square bracket cube minus 1 minus 2 omega plus omega square whole cube is equals to 65. Now see this, that is 2 is written as in this manner, that is 1 plus omega square bracket raised to 3 in bracket 1 minus 2 omega minus 1 minus omega whole bracket cube. That is plus 1 minus 1 get cancelled. 1 plus omega square in the first bracket becomes 0. That is 1 cube. Overall it is 1. What about the next? Minus 4 omega bracket cube means what? That is a minus 64 omega cube, and overall it becomes, that is a plus, and value of the omega cube is 1. That is 1 plus 64, that is equals to 65. Very simple examples. If you do the practice, then you will get the easy. Now next, 3 plus 3 omega plus 5 omega square bracket raised to 3x minus 2 plus 6 omega plus 2 omega square bracket raised to 3 is equals to 0. Now see this, how it is written. That is a 3 plus 3 omega. From these two terms, he take the 3 as common. From the first bracket, plus 5 omega square and bracket raised to 6 minus 2 in bracket 1 plus omega square plus 6 omega. That is from first and last term for the second bracket. Bracket raised to 3, I forget. Okay. But what is the 1 plus omega? 1 plus omega is a minus omega square. It's solved very each and every steps I had written there. You will understand very easily. That is a 2 omega square bracket raised to 6 minus 4 omega bracket raised to 3. Now again, that is a 2 raised to 6 and omega raised to 12 minus 4 omega 4 raised to 3 and omega raised to 3. Therefore, 2 raised to 6 means what? 64. And omega cube and bracket raised to 4 minus 4 raised to 3 means what? 64. Omega cube is 1 and overall 64 minus 64 and its value is 0. Now the next is, therefore LHS is equals to RHS. Now in the next example is very also interesting example. How there is omega is a balance. That is a LHS is equals to A plus B omega plus C omega square upon C plus A omega plus B omega square. Mathematics is very interesting subject. You can adjust it like this. That is multiply the numerator and the denominator by omega. Then what you are getting? That is A omega plus B omega square plus C omega cube. And what's happening to the denominator? Keep that omega as it is. That is A omega plus B omega square plus C into omega into omega. Therefore, the numerator bracket and denominator bracket both are same. C omega square to the numerator. The value of omega cube is 1 and it is written as A omega plus B omega square plus C, and to the denominator A omega plus B omega square plus C into omega, and overall it is 1 upon omega. Now 1 upon omega is find out in a very different manner. There is a find again multiplied to the numerator and denominator by omega square. That is omega square upon omega cube, and that is equals to omega cube means again 1, and that's you are getting the omega square, and which is nothing but the RHS. It's very nice example. This is also very interesting examples. It's very easy example. बघितल्यानंतर तुम्हाला अशी झटक्यात आयडिया आली पाहिजे की how it has been solved. It requires too much practice and practice. That is A plus A omega square plus B omega plus B omega. And what about happening? Take A as common, then in bracket you are getting 1 plus omega square plus B in bracket 1 plus omega square. And what is happening? Both of them, that is 1 plus omega square, its a value 0, and overall it's a 0, and that is nothing but the RHS. Therefore LHS is equals to RHS. Now the next example number 8, in bracket A minus B omega a minus b omega square is equals to a cube minus b cube. It's very interesting. What are the four factors for a cube minus b cube? In first bracket a minus b, in second bracket a square plus ab plus b square. But we have already a minus b, therefore keep it as it is. And simplify only the two bracket, that is a in bracket a minus b omega square minus b omega in bracket a minus b omega square. Now multiplied with that a term, then you are getting like this, that is in bracket a omega a square minus ab, take ab as common, minus ab as common, then in bracket you are getting 1 plus omega square plus b square, and the value of omega cube is 1. Now in bracket a minus b, a square ab, 1 plus omega square is minus 1 by using our formula, and this is nothing but the expansion of a cube minus b cube, that is equals to a cube minus b cube. Now in the next, that is RHS, therefore LHS is equals to RHS. Now next, ninth example, a plus b bracket square plus a omega plus b omega square whole square plus a omega square plus b omega bracket square is equals to 6 times a b. Now see this, a plus b bracket square, expand it. Again expand this, a omega plus b omega bracket square. Now to expand this very carefully. There should be not silly mistake in the mathematics. If you have your example is wrong, then you will say that I had done their silly mistake. Therefore too much concentration is required in this case. Now see this, that is a 2 times AB plus 2 times AB omega cube plus 2 times AB omega cube. Now we have taken, that is the terms of a square and a square. I had shown with the green ink, that a square omega square plus a square omega raised to 4. And what about the last, b square plus b omega raised to 4 plus b square omega square, and that is equals to, therefore we have, that is a 2 times AB plus 2AB plus 2AB, that is the value of the omega cube is 1, and we substitute its values. Therefore 6 times AB plus a square in bracket 1 plus omega square plus b square in bracket 1 plus omega square, and 1 plus omega square is 0, and both brackets become 0. Therefore we are getting the answer 6AB. Therefore LHS is equals to RHS. If omega is a complex cube root of unity, find the value of 1 plus 1 upon omega. Now here 1 plus 1 upon omega is written in this manner, that is omega square plus 1 upon omega. But what is the value of 1 plus omega square? That is a minus omega upon minus omega, that is equals to the minus 1. Next is omega square plus omega cube plus omega raised to 4. Now take omega square as a common, then in bracket you are getting the 1 plus omega square, and its value is 0. Therefore, omega square plus omega cube omega raised to 4 that is equals to 0. Now the next example, 1 plus omega square bracket cube 1 plus omega square bracket cube is equals to 1 plus omega square bracket raised to 3. The value is 1 plus omega square is a minus omega bracket cube and that is a minus 1 omega cube. That is equals to minus 1. That is a 1 plus. Now next is 1 minus omega square bracket cube 1 in next bracket, that is 1 minus omega plus omega square bracket raised to 3. Now substitute the values, that is 1 take minus n is common, then you are getting the omega plus omega square bracket raised to 3. From the next we arrange the terms, that is the next bracket 1 plus omega square minus omega bracket cube. Now see this, omega plus omega square is minus 1 and in the next bracket 1 plus omega square is minus omega in the second bracket. Now what's happening? Minus minus become plus, that is a 2 raised to 3. That is a 1 plus 1 bracket raised to 3 minus omega raised to 3, that is a 2 raised to 3 minus omega cube, but what is value of the omega cube? Is 1, 8 minus 1, that is equals to 7. That is I forget, that is a 2. That is a 2 raised to 3 and omega raised to 3. That is 8 minus 8, that is equals to 0. Therefore, 1 minus omega square bracket cube plus 1 minus. Now next, 1 plus omega square, next bracket 1 plus omega raised to 4, 1 plus omega raised to 8. Again this is very easy, 1 plus omega square, 1 plus omega raised to 4 can be written as omega into omega raised to 3. 1 plus omega raised to 8 can be written as omega raised to 3 bracket square into omega square, overall it becomes omega raised to 8. Now 1 plus omega plus 1 plus omega square, 1 plus omega cube is 1 in the third bracket. In next bracket, omega cube is again 1. Therefore, it is written as 1 plus omega square in the last bracket. Therefore, simplify this only. 1 plus omega bracket square and 1 plus omega also bracket square. Therefore, again substitute the values. That is 1 plus omega means what? Minus omega square bracket square. And 1 plus omega square is a minus omega whole square, that is omega raised to 4 and omega square, that is omega raised to 6 and omega cube bracket square, that is 1 square, that is equals to 1. Now the next is, if alpha and beta are the complex cube root of unity, then show that alpha square plus beta square into alpha into beta is equals to 0. That is, we know that alpha square if we take, then it is a beta and beta square is equals to alpha. Therefore, LHS is equals to alpha square plus beta square plus alpha into beta. Therefore, alpha plus beta plus alpha into beta. Now, alpha is nothing but minus 1 plus I root 3 upon 2 and beta is minus 1 minus I root 3 upon 2. If you add these two terms, then you are getting the minus 1. Now see this, minus 1 plus I root 3 upon 2 plus minus 1 minus I root 3 upon 2. The addition, these two terms get cancelled. That is a minus 2 upon 2 and it is a minus 1. Therefore, alpha plus beta is minus 1. Now, alpha into beta, that is a product, minus I plus I root 3 upon 2 minus I plus I root 3 upon 2, that is equals to minus 1 minus I root 3 and minus 1 minus I root 3 upon 4, 2 into 2, 4. That is a minus 1 square minus I root 3 bracket square, and that is equals to 1 plus 3 upon 4, 4 upon 4, and that is equals to 1. That is alpha into beta is equals to 1. So number 1 and this is the number 2. Therefore, from 1, that is alpha plus beta plus alpha into beta, that is a minus 1 plus 1, and that is equals to 0. That is equals to RHS. And hence, alpha square plus beta square plus alpha into beta is equals to 0. Now next is alpha raised to 4. These values were required in the next examples, therefore I had written A and B. Alpha raised to 4 plus beta raised to 4 plus alpha raised to minus 1 into beta raised to minus 1. Now from above, that is alpha plus beta is minus 1 and alpha into beta is equals to 1. Now see this from A and B. From the above examples we have taken it. Now LHS. Alpha raised to 4 plus beta raised to 4, alpha raised to minus 1, beta raised to minus 1 into beta raised to minus 1. That is alpha raised to 4 plus beta raised to 4 plus 1 upon alpha into beta. But what is the value of alpha into beta is 1. Therefore, alpha raised to 4 plus beta raised to 4 plus 1. Now see this again. Alpha square plus beta square whole square minus 2 alpha square into beta square. That is, this term we are getting the extra, therefore we are subtracting minus 2 alpha square beta square. Now see this. Alpha plus beta bracket square minus 2 alpha square into beta square whole bracket square minus 2 alpha into beta bracket square plus 1. Again the simplification. That is alpha plus beta, that is a minus 1, and alpha into beta is 1 after substituting the values. Now see this, you are getting, that is 1 minus 2 bracket square and minus 2 plus 1, and overall it becomes 0. Therefore the value is 0. Now that is RHS. Therefore LHS is equals to RHS. If x is equals to a plus b, y is equals to alpha a plus beta b, and z is equals to a beta plus b alpha, where alpha and beta are the complex cube root of unity, then show that xyz is equals to a cube plus b cube. Therefore LHS is equals to, in bracket. Now here we are getting some confusions with alpha and a, beta and b. Now see this. That is x into y into z. That is also beta is equals to alpha square. Now normal multiplication is there. That is the value of the beta is replaced in the second step. That is alpha square. Now from the first bracket I am taking alpha as common. Some mistake is I had made there also. That is a beta instead of, there must be the b. Therefore alpha square in bracket a plus b, and for the second a in bracket a alpha plus b, and I am changing there again mistake, that is B, that is A alpha plus B, and the next is alpha square in bracket A plus B in bracket A alpha plus B plus alpha into B in bracket A alpha plus B bracket complete. Now next is alpha square A plus B, that is A square alpha plus AB alpha square plus alpha B square bracket complete. Now the next alpha square in bracket expansion of that bracket that is the multiplication of the A and B to the whole square bracket. Therefore, alpha square in bracket alpha A cube alpha plus A square B plus A square B alpha square plus alpha AB square plus A square B alpha plus AB square plus A B square alpha square plus alpha B cube, and written in the different ink also. From you can take the common as alpha in the next bracket A square B, in the next bracket AB square. Now in the first bracket you are getting the A cube plus B cube. In the second bracket you are getting the 0, and last bracket you are also getting the 0. Now what's happening next? That is 1 plus alpha square, that is equals to 0. That is alpha cube in bracket A cube plus B cube, and the value of the alpha cube, that is 1. Therefore alpha cube is 1. Therefore LHS is equals to RHS, and its value is A cube plus B cube. Now the next question. Again I had written the exercise 1.4 question number 7 directly. Use the Moivre's theorem. The following, that is the cos of 2 times theta plus I times sine of 2 times theta bracket raised to 7 upon cos of 4 theta plus I times sine of 4 theta bracket raised to 3. Now it is written that is e raised to 2I theta, that is z is equals to cos of 2 times theta plus I times sine of 2 times theta bracket raised to 7. That is considering that is also complex. R is equals to 1. Therefore e raised to 2I theta bracket raised to 7 upon e raised to 4I theta. Therefore cos of theta plus I times sine theta that is equals to e raised to I theta. Therefore e raised to 14I theta upon e raised to 12I theta, that is e raised to 14I theta minus e raised to 12I theta, that is equals to e raised to 2I theta, and it is written as that is cos of 2 times theta plus I times sine of 2 times theta. Now the next, z is equals to cos of 2 times theta plus I times sine of 2 theta. Then our next example, cos of 5 theta plus I times sine of 5 theta upon cos of 3 theta minus I times sine of 3 theta bracket square. Now see this again. Its value is e raised to 5 I theta upon e raised to minus 3 I theta on a whole square. I can written the formula. Therefore, cos theta minus I times sin theta, e raised to minus I theta means cos theta minus I times sin theta. Therefore, e raised to 5 I theta minus upon e raised to minus 6 I theta, and overall it becomes plus by using the law of indices. Therefore, e raised to 11 I theta, that is the cos of 11 I theta, 11 theta plus I times 11 theta. Therefore, z is equals to cos of 11 theta plus I times sin of 11 theta. And the next example, this is the last example, that is the cos of 7 pi by 13 plus I times 7 pi by 13 bracket is to 4 upon cos of 4 pi by 13 minus I times sin of 4 pi by 13 bracket is to 6. Now see this, it is in this manner, that is e raised to 7 pi by 13 bracket is to 4 upon e raised to minus 4 pi by 13 bracket is to 6. Therefore, e raised to I theta is equals to cos theta plus I times sin theta. Therefore, e raised to 28 pi by 13 upon e raised to minus 24 pi by 13, and that is equals to e raised to 28 pi by 13. Minus and minus become plus by using the law of indices. Therefore, e raised to 28 pi by 13 I plus 24 pi by 13 I. Take their addition, it becomes 52 pi by 13 I. That is nothing but the e raised to 4 pi I. Therefore, e raised to 4 pi I. Therefore, that is the cos of 4 pi plus I times sin of 4 pi. Therefore, z is equals to 1. That is the cos of 4 pi is 1 and sin of 4 pi is 0. Z is equals to 1. And we have completed the question number 7 here. See the value. How the cos of 4 pi is 1 and sin of 4 pi is 0. Now we have completed question number 1 to 5 and the question number 7. Now we'll see in the next video the remaining question of the exercise 1.4. Till then, goodbye. Now in this way we have completed the Moivre's theorem and the complex cube root of unity and the examples repeating on these two topics. That is exercise 1.4, question number 1 to 5 and the 7. I hope that you have understand all these examples. If you have any doubt, write in the comment section. And also, if you are new for this channel, then subscribe it and share with your needy friends. Now we'll see in the next video. Till then, goodbye.